Hey everybody, welcome back to the Metal Mill 52 workshop. This is going to be a segment, just a short, hopefully introductory segment, talk about a lot of things with the Quorn Tool and Cutter Grinder. And I'm very pleased that I did get the bed bars, and I'll show you more about that in a minute. I haven't got the bed bars, I've got the bed bar material in the mail. But some of the things I've been working on just this week, I realized looking at Tom Blough's website, when he machined his castings, he had a very large angle plate, and I did not have a large angle plate like that. So I showed this. This is a piece of aluminum. It was once part of an engine stand, I believe, that the military used. My buddy Russ got some of this as scrap material, and we've used it for, he and I split it, and we've used it for a lot of different things. I made a lot of my Gingrey shaper out of this aluminum material. It's welded there, and it's got this welded in brace in the middle. So what I did last weekend, I went ahead and cleaned this up. I milled that off perfectly square, so I do have a nice angle. And I noticed as I was machining these surfaces, there was some vibration. So, and that's always a telltale sign of flexing. So what I decided to do was cut some braces. I cut some angle plate, some plate aluminum about 1/4 inch thick, 1/4 or 5/16, I forget, and drilled and tapped into the angle piece itself. So it's reinforced at least, and I think it will function as an angle plate. My idea is, I don't know if y'all can see this, but let me set it there. Yeah. So I noticed on Tom Blough's website, he had his pieces like this, and they were bolted in here, some fashion like that, all clamped down, and then he bored the bed bar holes from the top through the small piece, but he did them simultaneously so that the holes were exactly the same distance apart, which isn't a really big problem for me with my mill because I have a DRO, but it also ensured that the holes are exactly in the same orientation, the same height from the base, and exactly the same size. So I'm going to try to replicate that when I do mine. I have not yet received my drawings from Gary Martin at Martin Model and Pattern yet, so I'm going to hold off to machine the castings till I get those drawings from him. I may do the bases. I noticed that Tom Blough, he'd put the castings in his mill vise and then machined off the base so that he could put them flat up against the fixed jaw and then machine flat the inside faces. I may do that because I know regardless of what happens, I'm going to do that function. Speaking of Tom Blough's website, I also noticed, see, on his castings, this is the right hand casting, he actually had, it looks like it's cast into it, 2 little extra feet that end up getting milled off. And I thought, that's a really good idea because you have to put this thing inside the vise to mill this face flat, and the extra feet in there help, give it a lot of stability probably for that machining process. So what I did, I thought about some different options, thought about drilling and tapping through the casting, trying different functions. Can you solder it on, silver solder, steel to cast iron? You probably can. I think it can be done. But if you've watched my channel long enough, you know I'm a big believer in JB Weld. So it's a great epoxy. I mean, people put it down, but if you look at somebody like Mr. Pete, and there are several others, I mean, they'll use JB Weld for different functions, and it's a fantastic epoxy if you do it right. So I cleaned off these parts. I got a piece of, it's about 5/16 inch steel and about 1.25 inches, probably 1.25 inches square, something like that. So I cleaned it off really good, and that and the inside of the casting, made sure there was no burrs. Then I mixed up a little batch of WD-40 of JB Weld and put it on there and clamped it and let it sit overnight. So that's just a simple thing I could do during the week, and it's nice and solid now. So I'll be able to put this in, machine that flat, and then when I put it up against the fixed vise to the fixed jaw of the vise to mill this flat, it'll have a nice stable leg. Then when I get all done, I could just heat up the JB weld and loosen it and, you know, scrape it off, sand it off later. So that's one thing I did in preparation. A couple of simple things I did to get ready for the machining of the actual castings. So the next things that I'm hoping to accomplish this weekend, and I'll do segments about this. I did get the bed bar. I opted to use again the stainless. This is 303 stainless, and it's a 36-inch piece and 1-inch diameter, of course. And this is what they call bearing shaft quality. So it's not hardened necessarily on the outside, but it is ground, and it has supposedly like within a half a thou or something, maybe even more accurate than that. But the company I got it from, it was, let's see, I've ordered from these guys before, but it's been a while since I ordered. It is, what's the name of them? They do small quantities. I heard it. Here's the invoice they sent me. I don't want to say the wrong name. Speedy Metals LLC. They're up in New Berlin, Wisconsin, and this is no endorsement, you know, no paid endorsement, or for sure. I mean, I've paid for everything I bought from them, but they've been really good to deal with. They have their logo is it's like a Superman logo. So Speedy Metals in Wisconsin, and the prices are decent, and the quality of everything I've ever bought from them has been fantastic. So a lot of the small orders that I've made for the different 12L14 steel, bronze and brass and stuff, you know, if you can't find it on eBay, then go to somebody like Speedy Metals. There's a few other suppliers that are good, but I do like Speedy Metals. I'm really happy with them. So the next steps are to cut this thing and to machine the edges perfectly flat on most of them, and one side gets drilled a 13/32 hole with a flat bottom for the spring for the front bar. So I will do that, and also I need to make a 13/32 flat bottom drill, and I'll cover that. I've talked about that in the past when I did the series on making the brass live steam fittings, especially the quick start valves, and machining the PM Research brass and bronze valves. They require a flat bottom and oddball sizes. You know, you could kind of use an end mill for some of it, but making a flat bottom drill is not that hard. And maybe I'll do a segment part of this, at least show what I do. I can describe it very quickly. I get an inexpensive one, usually one of those inexpensive sets from Harbor Freight that you can buy for like $8 or $10. And I have a whole set that I've dedicated that just those are ones that when I need a flat bottom drill, I go to that set, I cut it off, and I make a flat bottom drill out of that set. So I've got one case that has all of those in it, and I can show that later too. But I simply use, because it's tool steel, it's going to be hard to cut, so I use a Dremel cutter with a cutting disc in it, and to lop off the pointed end of the drill, lop it off flat, and then the only other tricky thing, you need to grind it flat to make sure you're actually 180 degrees across the side, and then you have to grind in relief angles, because the thing's not going to cut if it's just perfectly flat. It'll just rub against the surface there. So you relieve it back in the same way that you would relieve a regular drill. If you ever look at them, you know that you got the point, but you've got a relief angle on either side. So this is just the same thing, except it's flat with a relief angle, you know, on either side of either flute of the drill. So I'll need to make that up, cut that, make this, and then when I get the casting, maybe machine the castings a little bit. Maybe tomorrow I'll do that, and when I get the drawings, then I'll be more inclined to go to town on that. So thanks again, everybody. Stay tuned for the next segment. Hey everybody, I just finished drilling the flat bottom for the spring. I've cut and faced both of the bed bars, the 1-inch stainless steel, and I just wanted to show this for a second. I actually didn't need to make a new flat bottom drill for the 13/32. It's one size up from 3/8 inch, And I guess some of the valves or something that I've made in the past use exactly that same thing, because sure enough, I looked in my collection of flat bottom drills and there was already one made. But I wanted to show, here is the drill I used just before I used it, and you can see the shoulder, the point. What I do is I'll use a feeler gauge or something, and I'll measure after I've drilled down from the point, from the point at the edge of the surface. I'll go down 2.5 inches. That's the depth of the hole that's required. And then once I've got that done, I use step drills, center drill and step drills to get the 13/32 inch space. And then the very last step, I'll go ahead and put the flat bottom drill in. And like I said, I didn't have to make one in this case. Let me unlock it for you here, and I'll show you the difference. There's the flat bottom drill, and as I said, the way I make them, actually I have this little technique where I'll wrap a piece of painter's tape, so that bright blue painter's tape around it, so I can see where I'm cutting, and then I cut them off with the Dremel wheel cutoff, and then I just grind in a relief. Let me show you the side. It's not much, it's probably 5 degrees that I back off, just so that it cuts, and so it's only cutting that distance. I don't know if I can hold them side by side, but it's only cutting the distance from the shoulder. There we go. You kind of get, hopefully you get the idea, but it's not cutting much. It'll cut in and just cut the angle of the shoulder down to the bottom. So that's what I use. That's the flat bottom drill. So anyway, I've finished both of those. I'll cut away now, and I'm going to take I'll clean up the opening a little bit with a countersink. And I've already filed and cleaned that end off, and I did the other end. I'll show you the bars, and we'll talk about that in just a minute. Hey folks, for this segment I wanted to follow up on the thing with the flat bottom drill bits. Like I said, I actually had a 13/32 flat bottom one, and this is the index that I was talking about. You can see, whoa, sorry about the noise, but there's a few that I've needed different sizes. I've made the flat bottoms for, here's a little short one down there. Dang it. Sorry about the noise. Anyway, I'll quit messing with this, but you can get these inexpensive sets. This is just a black oxide set, and I have a bunch of these, the smaller ones that I think I've made flat bottoms. Here's one that must have been the size for the some of those valves I made, but kind of a cool thing, if you're going to get into a lot of this stuff, just get you an extra spare set. I forgot I had the nice steel case there that I have kept those in. So, all right, enough about that. Let's talk about the bed bars for a second. So what I opted to do, in case you're wondering, these things they're the 1-inch stainless, 303 stainless that I got from Speedy Metals in Wisconsin. And this is the back bar, and what I did is I made it 16 inches long, and of course the stock dimension is for a 13-inch bar, but I went ahead and made this 3 inches longer on purpose. Main reason is everything I read on the Quorn owners group, they all said that they had either made them 3 or 4 inches longer or wished they had, and it seems like a very good idea to me. Here's the front one that has the flat bottom hole in it for the spring, the 3/8 inch spring, and then the ultra smooth shiny finish there that the micrometer screw will bear against. So that one's a little shorter. That's 15 3/8 long, so a little bit shorter for the 5/8 shorter for the micrometer screw to go into the end there. So that's the bed bar length, and like I said, the main reason, I could have made it a little bit longer than that, but I decided not to because this just looked like the right length. A lot of people said they made theirs this length, and I was thinking, you'll have the vertical column here, it'll go in here, and you've got the motor and the wheel head and all that assembly. So the grinding wheel is going to be here where my hand is. There's basically the tilting assembly that has the tool holder in, And depending on what size tool you're doing, it'd be really, oftentimes having an extra couple of inches of travel is very helpful. So that's why I made them 3 inches longer than they call for in the book. All right, next segment I'll talk about a little bit of the machining. In this segment, I just wanted to show the setup. I'm going to be using what Tom Blough used in his machining. This is the left-hand side, obviously. Before I got to this place, the first thing I did was to take a Dremel with a little grinding stone, and I cleaned out the core holes to make sure there's no little nodules in there. And then I made sure the vise was indicated and trammed parallel with the x-axis. It's not going to be critical in this, but I also made sure the vise itself was level, and I can show that later. That will be more critical for the next step of the process. So right now, this is the unmachined castings I'm getting ready to machine. My plan is to only take off the minimum amount possible, probably about a 1/16 or an 1/8 of an inch, something like that, just to give me a good base, just clean them up. So I know, well, I said an 1/8, that's 0.125, so if I can get away with less than that, like 100 thousandths, certainly we'll do that. So I will start that in just a second, bring you back when that's complete. Hey folks, for this segment, I just wanted to show the machined base of the left-hand casting. I've basically copied Tom Blough's setup. I used a couple of steel rods across the vise jaws, and it's hard to see in here, but I used plastic on both sides, because I noticed if I didn't, there was a tendency for rockiness. So I'm pretty pleased about how that came out. Machined out good. I took a little bit more off than I was hoping to. Ended up taking about 170 thousandths off the bottom. So basically what I'm going to do is leave that right now, and I will see how that works with the smaller casting. I'll get that set up and basically machine the bottom. Well, first I'm going to deburr it. It's got a sharp edge all the way around, but I'll file it off nice and smooth, clean it up. I put a magnet inside a shopping bag there, and I'll brush off the dust, the cast iron dust. You can see it sticks to the magnet there. That's an easy way to clean up. So I'll get that all cleaned up and basically repeat the process with the right-hand side casting. All right, really happy, folks. I got the, as you can see, the small right-hand section with its little JB welded on steel tab. Got that machined. I left the setting the same to machine this, so that this is exactly the same height setting as the finished product on the left-hand side, the larger side. I did, and it was going to be a lot to remove. I didn't realize I left so much sticking up, so I actually crept up on this, but I got it to exactly the same, the 0 setting there, and exactly the same 171 thousandths and 4/10. I haven't messed with the Z. It's been locked there, if you're familiar with Bridgeport. So anyway, and then I ran the cutter over here just to see and make sure it's exactly the same. So very happy. I ended up not using my plastic pieces. I did not need those for here. It's stayed secure enough, and you can tell, the steel bars are tight, so I feel like I have good contact there, and very level and even. So really happy about that. Now we'll update you. The next thing, I don't think I'm going to do it tonight, but I'll probably during the week go ahead and machine the insides flat and keep making progress. So maybe I'll go ahead and upload the video at this point. There's just some of the PME stuff. I just might as well cover that. I did use the level, this is a good Starrett level. It's to make sure my vise was level on the machine, which will be really critical for the next step, because I'm going to lay the casting inside the vise and make sure it's level using that 6-inch Starrett level there. So because the bottom of the vise is level, I know that, and the head's in tram and all that stuff, I know that when I take a cleanup cut inside here that it will be right and as level as I can possibly get it. So one more thing, since I realized I hadn't talked about cutters lately, what I'm using to clean up the cast iron is, it's a carbide indexable head, and it just has the 2 cutters in it. It was relatively inexpensive. I think I bought it from Enco back in the good old days, which is now part of MSC. And these are the, I can hardly read that, TP, I checked anyway, if you can see that, yeah, TPG 322, and I guess the size is TCN 55. You get a whole box of them, and they're probably a lot more expensive now. It's probably, it's when I started building the locomotive that I bought those, so 10 plus years ago. But as you can see, it works very well on cast iron, works okay on steel too, and so that's the exact right inserts for it. I have another set for different types of metal. But real pleased. I'll probably, like I said, break it down for tonight, publish this video, and then during the week set these things and machine the inside faces. So thanks again, everybody. I will keep you posted.